Let's see, share screen. So we got through the syllabus, and the last thing there was this little note I added in here. Some of you all who've had me before may have seen that assignment. I very often give it. I'll tell you the story behind it. Is a couple years ago, summer of 2019, I think, the vice president for the School of IT, all the Ivy Techs around Indiana, she was down here for, well, she likes to go around and stop by the different campuses, but one of the times she came down here wanted to meet all the people that teach in the IT departments and some of the local businesses and stuff, and get things lined up with businesses all over the state. So she was down here and had meetings with a bunch of the local businesses that would be hiring IT people. And a couple of them mentioned that they had recently turned down people for 4-year degrees because their knowledge was 6 years old by the time a curriculum was put together, then put in place, and then those people went to a 4-year school. They're learning knowledge that was laid out 6 years earlier. So it was very out of date. And they hadn't really kept up on the changes and just kind of learned the basics from their things. So several businesses had told her that people with really nice looking 4-year degrees or beyond. Over the break, we were talking about I'm currently working on my master's degree in mathematics because that's what my plan to teach was before getting hired to teach software development. But and I haven't really changed that. But people with 4-year degrees or beyond, master's degrees or something, they had old knowledge. And technology changes quick. And people got turned down, and they hired people from 2-year schools, or some people that just had the knowledge instead of these people with these big fancy degrees because their knowledge was so out of date. And when she told us after meeting with the local businesses, she came over here to school and met with us, and she told us that. I thought, well, that's an easy thing to fix. So y'all are required to keep up to date on your technology, which is an important thing no matter what field you go into. Right? That's not just a technology thing now. But any field we go into, we want to be up to date on that field. We want to know what the latest knowledge. In healthcare, you need to. You want to know if you're working in healthcare, you need to keep up on what the latest medicines are, right? Doctors have to know what to prescribe to people and all that stuff. We live in a dynamic world, so things change. IT changes especially quickly. So it's very important to stay up to date on IT. So this assignment is basically a report. I didn't even put essay, it's just a summary. Just do a summary of 3 technologies from the last 6 months. And I put it in module 1, but this is just due this semester. At some point this semester, turn this in. So 1 to 2 pages total. So just a paragraph or 2 on each. Screenshots are nice if it's something you can download a free trial of and give it a try and write about your experiences in that summary, but not necessarily required. And screenshots don't count in the 2-page total. So 1 to 2 pages of written things that it's just a summary. And this is a software development course, so software development is preferred, but there have been a lot of advancing technology, and the point of this is just to make sure y'all are able to keep up on technology. That's something you're going to want to do in the field. Things change. We live in a dynamic world, so whatever industry you want to keep up on it, and really that amounts to reading news stories about it. So I put some links to, I guess, magazines. Well, this first one I clicked on is still a magazine. They'll still mail you one, but the online version. And just look through here and see what's progress, release new troubleshooting solution. Nope, I don't need the newsletter. So Asana stuff, released something new. And just kind of look through here. So JetBrains made some big improvements to the built-in quality control, quality platform stuff. That's a good one for software development. But just look at some of these articles, see if anything catches your interest. So along from being a short writing thing, it should be interesting too. Because surely you can find something for the last 6 months or a year or something that is fairly new, recent technology that is very interesting too. So just write about some things you find interesting. So it should be, yeah, that should make it very interesting, or a lot easier because you're looking at something. So architecture on database stuff, a new tool for .NET stuff. A lot of different articles, but I went, those buttons got in the way. I do not like this frame buttons. Can I move those to the bottom? There we go. That way I can close the tabs. But yeah, a couple different things here. And check whatever your interest lies in. Cybersecurity, that's a hot topic these days, right? So there's been a lot more events in cybersecurity than elsewhere. So if that's what you're interested in, check on some of those latest things. Just write about the latest stuff. Apple's fall conference was yesterday, right? Or the day before. You're a Mac person or iPhone user. There was some a lot of good news come out. I guess it was Monday. Blender is officially on. Apple is supporting the most popular 3D modeling software now.
That's what Blender is.
3D modeling software, really nice one. It's open source. It's scripted in Python, so that's actually something we'll look at in this course at some point.
It's open source and it's Mac supporting it.
That's unusual.
Right? Yeah. It's weird.
But Blender, it's been open source. It's been the most popular for a while, and you can do like Hollywood quality.
It's like everything that gets put on the App Store for Apple goes through like rigorous testing, right? Like they got to prove it, as opposed to Android where it's like more open source and stuff.
Yes. So somebody just did this tutorial the other day. I'm going to pull this up. Hopefully it goes through. So Blender's 3D modeling software. Right? So we're modeling things in 3Ds. And let's look, see if we can just get to the end result here. Yeah. So Hollywood quality. And look at the time it took him to make that. And this is a tutorial. That's explaining it.
Yeah, he didn't just like.
You can make that in 20 minutes with this software. Open source software for you to use. It is by far the most popular because it's so powerful. As it grew and grew and grew, right? So people at like DreamWorks and other companies out in Hollywood, the developers, they run through more than one idea, right? That relates to this class. They're not going to do just one idea and then stick with it and hope everything works perfectly, right? They're going to try every idea they have. And when they're doing that, the ideas that don't make it don't need scraps, so they often end up in open source stuff. And with 3D modeling, that's been Blender a lot. So, and now it's to the point that it's open source, free software, that in 20 minutes you can explain to somebody how to make that 3D environment. Make it and explain it that quickly. So
pretty rad.
What did I search? It's Bob Ross style landscape in Blender. If you search that, you can watch the video. And yeah, so those mountains were done with math equations. That's the type of math I actually want to study. U of L is very focused applications. So they don't do abstract stuff like come up with a series of fractal vectors that will generate a mountain, a realistic looking mountain with snow and trees and everything, just from math equations alone. So that's the sort of abstract stuff I'm hoping to get into. Or I like to do it right. But the new technology report, yeah, just look at something that seems interesting, pull that up. And that thing about Blender, we will look at Blender because Blender is scripted in Python. So we can, it's written in the language we're going to look at. So one of the things I would look at is the not starting from scratch. like this big piece of open source software. Open source means we can download it and add any button we want. We can download the source code and adjust it any way we want. And that was written in Python, the language we'll learn. We probably won't download the whole source code. We'll just do a plugin. It's also written in Blender, also written in Python. It kind of follows the same thing. We'll add to it. Maybe that there's some button or another that we would like to see in there that's not there, so we'll add one in and learn how to script that this semester. We'll look at that, but the technology report should be fairly straightforward and hopefully interesting. If you check the find some stuff you're interested in. Obviously, it's a software development course, so software development is preferred, but it is not a hard requirement. Anything new technology, and there's been a lot of it. If you're interested in robotics, right? Anybody see the videos that Boston Dynamics newest robots are doing parkour now? Like synchronized parkour.
What?
Yeah, we might as well look at this. This is a very, very interesting thing. This probably won't come through in the across the Zoom call very well. Parkour robots. Use Google parkour robots, and yeah, it's about a minute long. That's a deep learning algorithms. Robots created themselves. They move their obstacle course around, and the robots figure it out themselves. So that's technology from the last 6 months. That's August. So that would be a very interesting one to summarize.
I was just asking because I saw this one video where a guy had one of those robots, but it came like with a remote control to it.
Yeah, they have some of those. There's a lot of different kinds.
Yeah, the video was like he was making a carriage and he had like the robot pull it.
Oh yeah, there's all kinds of things. It's fun to mess with robotic stuff. The unmade processes, I really enjoy doing that. That's one of the things. Yeah, like I was planning on being a math teacher, and right as I finished the initial paperwork to get started into that, I happened to see Skip a couple months before that, and he was looking for a software development instructor, and he knew how to program and work in the IT field. And he'd sent me some IT people with questions and stuff, so he knew I had experience with it. And I was like, oh, well, I like to programming is what I do on the weekends for fun. Oftentimes in embedded systems with robotics and automating things. So any questions about course policies? Everybody get the username and password. Were you ever able to get in, William? Did you get that working? I don't know if you can hear me. Can you also hear me?
I'm here. You were just buried under open windows. No, like I said, I'll just try it later.
Okay, make sure you go to the rooms for 158 or 162A. Oh,
well, I'm still trying to access it remotely
oh,
on the desktop.
So the key thing on that, I'll pull up this before we get started into the course material. Is that is a useful thing to practice. It's basically just using a computer across the internet, but some of the things are different. Like the keyboard shortcuts will be local. So if you go to the written instructions, just kind of click this link here. Or oh, for some reason it's not copyable there, wherever I was looking at it. And don't enter the stuff here. So you don't want to use the regular login, you want to use this down at the bottom, the SAML authentication. So you have to click this, and then that goes to the regular Ivy Tech login. Which I'm already signed in, so it remembered me. But did you do that, William?
I'm still trying to, like I said, use my remote access login. And, it only gives me two options, the SAML credentials and the username and password.
So if you click the use SAML, it should go, I'm already logged in, but it should go to that green page like you see when you go to log into Ivy Learn and iIvy. The regular Ivy Tech login. And then that one,
Okay. I have a different icon that I had from last semester. So
okay,
should I just dump it and start over?
that might be easier sometimes. Yeah, so once you get in there, that first one, you click the SAML authentication, SAML authentication. That is your regular Ivy Tech username and password, like you use for your email and Ivy Learn. And then if you go into the 158 or 162 labs, that's these here. That's the one I just erased from the board.
Okay.
So, yeah, that's the access to that, and I will contact Keith, see if I can figure out why that wasn't working. Any other questions about course policies before we get started into some content this evening? Okay, so I don't hear any questions. I'm gonna stop the screen share. And yeah, so if you're looking at everybody's thumbnails, up in the top right corner of the black area there on Zoom is a button that says view. And if you click that, it'll switch to speaker, which everybody else on the Zoom call appears to be muted right now. So if you switch to the speaker view, then my thumbnail will take up the whole screen, be a whole lot easier to see what I'm going to write on the board. Because I like analogies. I like to talk about analogies and metaphors and similes and relate the knowledge about this to other things to understand it. Because we do kind of know what it really is, right? It's an electrical system, which, so to start with, you can plot out, maybe do a mathematical plot of voltage over time. And what a computer is doing is we assign some sort of threshold. There's just some level here. It's very common anymore to have 1.2 volts. If we're going to embed systems, use embedded systems where we're going to be working with motors and build robots and things, we often have 5 volts or 3.3 volts, because those can turn on bigger things, right? Like I often refer to IoT stuff. Well, I have an IoT lab we're going to work in somewhere along the way, just some basic stuff, super basic stuff to see it, because that's an important thing for software developers to know anymore, right? We need to know how to program a coffee maker, how to access the refrigerator across the internet. We won't get super detailed about it, just some basic stuff, but it is kind of a key concept. But things like, well, 5 volts isn't going to turn on anything in your kitchen. 5 volts isn't going to run a coffee maker. But 5 volts will turn on a bigger switch. 5 volts could be used to turn on a switch that can handle 250 volts. And then that 250 volt switch that handles 250 volts could turn on an even bigger switch that handles several megavolts. That's what happens in the like power plants. where they have megawatts, megavoltages and gigavoltages, lots and lots of electricity. But in the control room, they just have a little bit button. Two little bit buttons on their computer using 1.2, 3.3, or 5 volts, a small amount of electricity. But we know it's really an electrical thing. But whatever our voltage is, there's going to be some just variance to it. Varies, you know, the electricity varies slightly, and it might be below that threshold or it might be above it. Below it or above it, below it, and they come above it. And basically, if it's below that threshold, we'll say it's low. And if it's above it, we'll say it's high. Low or high voltage gives us two states, binary thing to work with, and everybody here at the, I think that's SDEV 120 class, you remember going over the binary. It's a low or high state of voltage. Usually we'll use 1 or 0 to represent that. And the reason being that those are really easy symbols to write, so we can tell at a glance the difference between them. And when learning, we say 1 means, we often refer to 1 as on and 0 as off. And that's what I'm going to say in the for this class. I'm going to stick with that convention. 1 is on. If we say 1, I mean on, and 0 means off. But that's not really the numbers here, right? Those are just symbols representing this. And we can turn things on with the 0 when we actually go to apply it. That doesn't mean we do that to simplify it, right? It's complicated enough to learn. It's complex enough learning it. If this always means on and this always means off. But once we get familiarized with it, for example, screens, all these screens right here, every modern screen, exactly half of those pixels turn on with the 1, and exactly half of those pixels turn on with the 0 in order to minimize the clutter. So once we get past the learning it and the simplification, that doesn't necessarily mean on or off. Since I'm talking about this and this in electrical engineering, the 1s and 0s really mean source the current or sink the current. That's the actual terms for what they mean and how we use them to turn things on and off. But that's electrical engineering. We're not going to get into that. But like I said, every modern screen, half of those pixels turn on with a 1, and half of those pixels turn on with a 0 in order to minimize the clutter of wiring. The wires are so small we don't see them, but we know they're there, right? Every individual pixel has to be wired together as part of a circuit. So half of them turn on with a 1, half of them turn on with 0 to minimize that wiring. And we shuffle it around and get an effect. Y'all have probably seen where sometimes screens can take a lot of damage. And you see a highly damaged screen. It just happens a lot on phones, especially. But sometimes on laptops and desktop monitors, there'll be a lot of damage on the screen, and then other screens, like a little bit in it, will just shut the whole thing down. And that's because they electrical engineers adjusted it, used some things come on with the 1, some things come on with the 0 to minimize the clutter. And then they shuffled that clutter of wiring around so that there are just some very sensitive spots. Odds are we won't hit that sensitive spot, and then the entire rest of the screen will take tons and tons of damage. But if that sensitive spot gets damaged, the screen can go out with very little. Y'all have probably seen that happen in our modern world. The screen's everywhere. But for this class, we are going to use on and off, and I will explicitly state it otherwise. But that's really means we're either above a threshold or below a threshold of electricity. And well, what can we really pull from our own experience about electricity? pretty much just this thing right here, right? So I run my feet on the concrete, they come over here and touch one of these things. Well, this is a computer, I'd say, so it's the doorknob. But you don't know what I'm talking about, right? Run my feet on the carpet, touch a doorknob and get shocked. That's what's really going on there. That would be a 1. The electricity is on. A voltage is the potential, so there's a potential that something could happen. So if we rub our feet on the carpet, there's a potential that that doorknob could shock us. So that is a high voltage. That's our experience for it, but that experience doesn't help us develop software to do things with the machine, right? So I like analogies. And this is called von Neumann architecture. It's somebody's name. I'll put it up here. Von Neumann. I hope that shows up a little on the screen. Those of you on the Zoom call, can you read that stuff I'm writing on the board? See it some. I know it's not perfect.
Yeah, I can read it.
It's legible.
You can't read it? Okay. Yeah, so this is called von Neumann architecture. That's our binary states, on or off and doing stuff with that. And I bring this up because we could also have non-von Neumann architecture. Because like over here, this voltage on this grid, we have that threshold for von Neumann.
I don't know if your microphone died or what happened, but we cannot hear anything that you're saying.
Oh, it's good now.
Oh, can you hear me now?
Yep, now
Yeah.
we can hear you.
All good.
So don't know what happened there. How long ago did it cut off? A couple seconds ago? That box
About
just
3
popped up.
minutes.
Oh, well, it took a minute to finish it. Did you hear me say this guy's name, von Neumann?
Yeah, you were just starting to talk about non-von Neumann.
Okay, yes. So, yeah, because we have this entire range of voltages. And I was pointing out here, when this one jumped way up, right? It looked like it was going to be a 1. But from what I drew here, maybe we got to 1.1 volts instead of that 1.2 voltage threshold. So that's still a 0. But looking at this chart, it looks like that should have went up to a 1. So non-von Neumann is instead of just the binary states, which allow us to do all the Boolean algebra like we saw in SDEV 120 with the binary stuff, which we will review briefly. There's this entire range of voltages. So instead of just one threshold, non-von Neumann would use the entire range. And there's some really nice theories for about 80 years because nobody could make it work. And around fall, a couple years ago, about 3 years ago now, in the fall, in October, some researchers finally had a breakthrough and made non-von Neumann computer architecture work, so we could use the entire range of voltages. And obviously, that's research, very, very recent research. It's not in the technological field, but they did finally make it happen. So it's something we're liable to see in our working careers, but that's going to work its way into technology, which would definitely help with things like this. Because should that spot be a 0 or a 1? It's really hard to tell, right? And if we have to break it down and look at all the ones and zeros in the actual machine language, it's very, very difficult to figure out what went wrong there. So if we have the entire range, we're going to end up with those little near misses of the threshold. But it's something that's coming up. And electricity, like I was saying, it's kind of hard to visualize that. We know turning the lights on and off, right? Well, that microphone instance a second ago, it just suddenly shut off. It was on and then it suddenly shut off. Or if I come turn the lights off, I could walk back here to the light switch. The lights in this room are on. So right now, there's a 1 on that wire. There's not a whole lot of different things. If I flip this switch, now there's a 0 on that wire the whole way. Turn it back on, there's a 1. So we kind of know that stuff's happening, which is something that maybe to mark here because it's probably going to show up somewhere if we talk about wires and stuff and we do an IoT lab. We usually have a wire. And I can just point out with the light switch, it's either a 1 or it's a 0 down the whole wire. But that doesn't help us understand what's going on in the code. So usually we'll write all of that code it's going to go back and forth between. But we do understand it's one or the other the whole time, right? That wire is carrying the signal that's on or off, just like the light switch. I just thought I'd point that out because a standard way of representing it, and we want to keep in mind what's real. With electricity, it's hard to really visualize that. Because the lights aren't, that's an application of it. That's not physical experience with the electricity, like say, shocking ourselves on a doorknob is. And that's really hard to draw from experience. So I like to do analogies. So I wanted to start with an analogy about software. I guess I've been talking for a minute and just used the word to start with. Took me a minute to get to the start with point. Start with an analogy and try to make stuff make sense. And I'll do that throughout the semester. We'll briefly mention the exact thing. Is it okay if I erase this? I would just like to make sure before, but that doesn't help us figure out what to do in the code, right? We want to be aware that that's what's really happening, but that's not really helping us debug a piece of software. Right now, everything's pretty much still on Neumann Architecture, except for some research, but the other stuff probably is coming, so we want to be aware of it. Be aware of its existence, basically. So like analogies, comparisons, metaphors, similes, things that we have experienced. And so I'll often talk about things outside of programming to help these concepts make sense. And that's where I was going to start with. Programming language is a tool. That's really what it is. What gets done with that tool and how it's done is entirely up to the programmer. So questions I've often seen when people are struggling, and like, especially in the SDEV 120 class, is like, how to write an if statement. So you help them work their way through it, and they get to the next problem, and I'm not sure what to do. And it's like, try an if statement or a selection structure. And then it turns out to be a different selection structure, and it completely confuses them. Like, that's not what it was a moment ago. So the selection structure is the tool, and there's lots of ways we can use it. So for an analogy, think of a hammer. Did that show up on the screen? Let me try to do all that bigger. Okay, yeah. I guess I just need to write on the whiteboard like this. I burned through a lot of markers this semester that way, but it looks like it's showing up on the video. So just a basic hammer. What is a hammer? It's a tool, right? So So a hammer is a combination of levers. We have a fulcrum point somewhere up here. And a fulcrum point somewhere over here. Those might move slightly depending on how we're using it. And then there's our stick man using it. So there's actually another fulcrum over in their arm, but a combination of levers. If we move the fulcrum point where that rotates off center, then we could lift a very heavy weight on this short side of the lever with a little bit of pressure on the long side and adjust our forces that way. Everybody's kind of encountered levers before, right? They show up quite a bit in our world. But a hammer is actually a combination of levers. We have several fulcrum points put together to redistribute forces. And typically, when we use this, we use a hammer by pushing with that side and pulling with that side. That makes sense to everybody? Seen a hammer before? We have one side where we hit things, or the little call part where we pry things out. Yeah, usually it's fast enough that we say hit and pry, not push and pull, because it goes fast, but we can push things slowly with a hammer. Right? That's what the tool does. But that's not the only way to use the tool. On construction sites, I've often seen hammers used as door stops. It's a nice heavy object that will keep the door open, right? When you're carrying in the rest of the materials, prop the door open, use a nice big hammer. That's going to hold the door open. But will we ever say that a hammer is always used as a door stop? That's not what tools are. And programming languages are the same way. It's a tool. We have things we typically do with it. Typically, if we need to put a selection structure together, we'll use an if-else block. We want one or the other thing to happen based on some condition. But sometimes maybe we'll use exception handling. We'll just try to do something and then we'll do something else if it throws an error. Instead of putting together a normal, nice, organized if-else block. There's different ways we can put these things together. We have the tools. So in this class, we're kind of looking at the tool, getting started with it. But just like a hammer, by no means are we going to be able to see everything that can be done with that. Or when we see the normal usage for it, is it going to include everything that could possibly be done with it? Because we have a very small number of tools. And you would have seen them all in the SDEV 120 course. Really, we have 4 of them. There are 4 constructs. We'll talk about those in detail soon. And it takes 4 types of tools to solve any problem. Whether it's getting input from a user, getting some numbers from a user, doing some math and spitting out some output. There are 4 types of tools we need to do that. We call them our 4 constructs. And that's problem solving in general, not just computer stuff. The solution for the famous window world piece will involve the same types of tools because that's the tool for problem solving. And might as well list them out here. So we call them the 4 constructs. And that's the tools for problem solving. Tools necessary to solve problems. So we'll need a sequential tool, some sort of order for things to carry out. And with programming, so these are the tools for problem solving in general. In programming, that's nice because that's the order of the instructions that we feed into the computer. The machines have to have them in a certain order. So the sequence or the sequential tool is the order we feed those instructions in. But then we might need to make choices. We need a selection structure. Ways to make choices, branching, take different branches through our sequence. We don't want a sequence that looks like this. For more complicated problems, we need sequences that look like this. And have multiple paths that we could take. Might need a reiteration, repeat or reiterate things. Some sort of reiteration tool, ways to go back around. In all the programming languages we'll look at this semester, the textbook is all Python. It's going to be mostly Python. But after we've seen all of our tools in Python, I want to look at them in some other languages so that you can see it. Like, okay, you know how to do this in Python. Well, it only takes 45 minutes to pick up the syntax of doing this in PowerShell. And now you know how to do it in a second language. Another 30 minutes to pick up the syntax of doing it in Visual Basic. Then you know another language. Because they operate in very similar fashions. They're just different tools. And like there's different models of hammers. Right? You probably wouldn't want to use, go back to the hammer analogy. If you were building a house, you probably wouldn't use the same hammer to put the frame together, the 2x4 frames for the house, as you would for the finish molding, the finish floor molding or something, right? You want a big, heavy, solid hammer to put the frame together because, well, the frame's going to be hidden behind the door drywall, so it doesn't really matter how that looks. But the floor molding and the crown molding, those are the finished final things that you want to look really, really good. So you probably want a very small, delicate hammer to put those up. You wouldn't even use the same hammer for building an entire house. And programming languages are similar. They have different, each one has a different strengths and weaknesses. So usually we mix and match them to optimize what's going on. For those who have had, like, say, SDEV 153, you've seen that somewhat there. HTML, the HTML5 standards, we mix and match different types of languages. So like HTML is a markup language, which is the optimal way to pass data through a machine. That's almost the perfect way to pass information through a machine, because markup languages, every piece of data has the data, and then it also explains where it starts, where it stops, and markup languages end up with a lot of nested things, so it also says where it goes. So every piece of data has the information, not just it has the beginning, the end, what it is, and where it goes in relation to everything else. So markup languages are perfect for processing, great for the machine. So for websites, we use a markup language to pass our data through. And then we style that. Markup languages are terrible for style rules. We don't want to go through and set up all our style rules as attributes in the tag. For those who haven't seen that, you will probably see it at some point. But we don't want to set up attributes because markup languages are terrible for laying things out, choosing colors and stuff like that. Whereas cascading style sheets are kind of the optimal way to lay things out on a page, to define appearance stuff like what color it is, where it goes. Is it the left of the page, the right of the page? What goes before something, after it? If things are layered, what's in front, what's in back? So we mix and match languages like that all the time. And all across software development, we often do that. We mix and matches our languages based on each one's strengths or weaknesses to optimize what we want to do. But when learning it, it's a lot easier to learn it one at a time. So we're going to spend most of our time looking at Python. And then whenever we do look at other languages, we're going to step completely away from Python. So it's like, okay, we've seen this in Python, so today we're going to look at PowerShell. That's the one I usually show. Maybe Visual Basic, maybe something in the C family. Those will go very quickly, just to see that once you know how to do it in one language, you pick up syntax elsewhere. So I was talking about the 4 constructs, we need the reiteration thing. And all of the languages we're gonna look at, we'll see several, there are loops. So anything we look at in this course, we will have loops. Loops are a high level construct that the machines don't do naturally. So we will also take a look at recursion. But recursion is hard. So we have loops to work with, that makes it easy. But not every programming language has loops. But some way to repeat things. That's a tool necessary to solve problems. And our last tool is invocation. We need a way to jump out of our sequence, go someplace else, and then come back to our sequence, come back to the spot we left off at. In programming, that's going to be functions and methods. Jump out of our current sequence, do some other stuff, and then come back to where we were. But it's one of the core tools we need for problem solving in general. But those 4 things are enough to solve any problem. For us, programming problems, software development sort of problems, but in the real world, if you're hanging out with your friends and need to watching a movie or watching something on TV, come a commercial break, somebody's going to run to the kitchen and get drinks, and that problem will be solved with these things. So there's an order to it, right? When the commercial break starts, somebody asks everybody else what they want to drink, stands up, moves to the kitchen, gets the drinks, comes back with them. There's a sequence to it. It's a selection structure. Maybe somebody wants water, wants ice water. Somebody else wants a soda without ice in it. I'm assuming a fully stocked fridge. Maybe somebody else wants sweet tea or something. But everybody wants something different to drink. So a selection structure of what to choose, what drink to choose, and what cup to pour it in. Reiteration, if there's a whole group of friends and we need to keep pouring those drinks. So I use reiteration as repetition with variance. So an analogy for that, I always have a lawnmower analogy. We will see this stuff again. We're kind of in preview mode. First day after policies, I always like to do preview stuff that we were talking about it more. But like a lawnmower, when we mow a yard, you get behind our lawnmower and push it along. It mows a strip. Then repetition, I'll use that for an exact copy. Because sometimes that's what we want. But with that analogy, repetition would be to get behind a lawnmower, mow that same strip. Go back and mow that same strip. So during lecture, I'll use the word reiteration for repetition with variance. So instead of the same strip, we mow, but then add some variety. We turn the lawnmower around and move over. So we mow the next strip of the yard. And that way we eventually finish mowing the yard. Some sort of reiteration. Or the drink example I was just talking about. Several drinks to pour, so pour a drink in 1 cup. Pour some water, put some ice in all the cups. That's a repetition. Then pour some water in one, cola in another, sweet tea in another, and kind of repeat the process. Invocation is somebody from somebody in one of your friends sitting there watching, still on the couch by the TV, says, "Oh, I changed my mind. I don't want ice in it." So we have to jump out of our sequence, take ice back out of the cup, and maybe put the water back in the cup without ice in it. So those are the tools to solve any problem, not just software problem. But software developers solve problems. That's what we're doing. So we definitely need these tools, and they're all built into our languages. The order we'll go through. If else structures, then we have some others, switch cases. We won't really see that one this semester. Maybe near the end, I'll pick a language that has a switch case, so we can see that. Because in some languages, it's faster because it's better for the machine. And in other languages, it's just added in there as a syntax because it's so common in the languages where it is faster. It's not always faster, we don't have it in Python, but multiple ways of making selections and reiteration, recursion, different types of loops, and ways to jump out of our sequence and get back to it, which is methods and functions, and object-oriented stuff. So we have all the tools built into the language. So that's what this class is about, is those tools. And then getting practice with those tools, learning to use them, getting practice over and over again. And then the last note I have on this analogy, the hammer thing here. Does owning a hammer make somebody a master carpenter?
No.
So same thing with programming languages. Knowing the language isn't really what makes us programmers. Well, that's the first step, right? Gotta know the language, but knowing how to implement an algorithm well is what makes a good program. We can often make it happen, right? Somebody that's not a master carpenter can probably pick up a hammer and make something. Or some other use of the tool, right? Prop a door open with a hammer. I don't need much skill at all with that. And programming languages as a tool are the same way. So I wanted to start with that analogy and talk about this as a tool. And then next week, we will get started into some quick review of the like computer math stuff we saw, working with binary code, reminder of what that meant. I know some people, we just went over that a couple weeks ago in this at 120 class, but for other people, it might have been a while since that 120 class. So we'll review some stuff, and then mostly we're going to do lots and lots of examples in Python. So the textbook covers, we'll be working along in examples in class, and I'll talk about experiences I have had with Python or programming in general. I first learned to program a very long time ago. It was so in fall of 1987 is when I finally got a computer out. Back then, that was the old DOS machines. And basically, I had to program to use them. So was some of that. Most of y'all are probably too young to remember this, but in the late 1980s, there basically it was like flipping a switch. There suddenly came a day that parents weren't allowed to leave their children at home anymore. Parents, had to go work, so they went to work, and the kids stayed home without supervision. Most of you young people probably, that doesn't make a lick of sense, right? The kids at home without supervision. It's like, well, the oldest kid was in charge. It was kind of supervision. The rule of the big brother or big sister. But in the late 1980s, that changed. That wasn't allowed anymore, and there weren't a lot of daycares and stuff, right? Because that was something new. So there weren't daycares all over the place like there are today. So one of the things that people were doing was summer school existed for the kids that maybe missed big sections of school from being sick, or the troublemakers that hadn't got a passing grade, and give them a chance to make up. So summer school existed, and then in summer of 1988, a whole lot of people just used summer school like a daycare. Like, can't leave our kids at home themselves, can't take off work, out of work, so they were using summer school as a daycare basically. And they were going to school, they wanted to keep that interesting. And one of the things they did was the music teacher's husband was programmed. So he came in and taught a bunch of us how to program on Apple IIs. Like, this was a long time ago. Black screens with green letters, and that was about all they did. Well, we started doing graphics on them. So we were programming, we learned how to manipulate them and stuff. But it's the late 80s, so the school didn't have a lot of nice computers. They were kind of old Apple IIs at that point, and it was in a flavor of the language BASIC. I don't think he ever said it at the time. I originally learned it, but that's when I learned to program. Then, and I do stuff off and on over the years. Then in summer of 1992, before the internet, we weren't farming anymore. So sitting on a farm, didn't have farm work to do. There was computers there, and I needed something to do. So I wrote my first thing that I called a game. It was back in summer of 1992. Just from trial and error, a stick man dribbled a basketball, and then a stick man dribble bounced around an orange circle, and then eventually threw that through an orange circle, or a solid orange sphere. Not sphere, it was 2D. So a solid orange circle that the stick man would bounce around and then throw through an open orange circle. I spent the summer just trial and error, figuring that out by trial and error. So I've been programming for a long time. I enjoy it. I have fun with it, doing that stuff. It was a lot harder back then because couldn't just Google it back then. I had to spend the whole summer just randomly trial and error with the few pieces, the basic tools we have in programming languages, and some rough images that a computer in 1992 could, home computer in 1992 could handle, until I figured out how to make those images move the way I wanted to, respond to different key presses and stuff. It took me all summer, and virtually nothing by today's standards, but I was very proud of it. And there wasn't any looking it up at the time. But I've been programming for a long time. I really enjoy it. That's kind of the sort of thing I do on the weekends, fun, get on the weekends for fun to relax. And then Skip mentioned the job teaching software development starting in 2018, a few years ago. I was like, well, programming is what I do on the weekend for fun. So I really like to teach that. Hopefully we'll have a lot of fun in the class. I'll talk about various things that I've learned over the years, little tips and things. Oh, that's not a good.
There's no alarm.
That's not,
I totally forgot that.
it sounds exactly like the fire alarm.
Yeah, it's not pleasant.
So yeah, well, I really enjoy doing this. Been teaching software development courses for a few years, so this course I've taught a few times, and kind of felt like I was getting a good little pattern going in my notes. So I write the lecture notes and leave lots of white space, then over and over again, as the class gets taught again and again and again, I'll fill it in with notes and make little adjustments over the years. But they changed the course shell, so the new course shell is still new to me. We'll figure out. Looked over it, everything looks good. In the past, I've been a little not happy with the automatic computer graded stuff like that textbook has. So one thing, give it a try in the textbook, and if you struggle with it and start to get aggravated, and you think your program should work, and the computer's saying it doesn't work, you're quite sure that it does. You can see the app, you can give it the inputs, get the right outputs. The computer's just telling you no. Send it to me and I'll manually grade it. Just download, copy and paste the files. But hopefully we'll have a lot of fun in this class. Be interesting stuff. I guess the first big thing is it's an active subject. We learn by doing, and we'll be working. Our doing part will be the programming in the Python programming language mostly. So you want to make sure and get Python installed so that we're ready to kind of start working on stuff. So there's the little IDE built into the textbook. That stands for Integrated Development Environment. But it is a very stripped down one. So there are other options. I put, where is it? On the module. Oh, I was already on module page. Module 1 somewhere is something about installing Python. Wasn't there? Oh, yeah. This assignment, choose your Python IDE. So make sure you get this done over the weekend. Well, for one, it's a setup assignment. So I don't accept those late, and they have to be done either way. So personally, I like text editors and just run it on the command prompt, which is probably what I will do in class. I'll use my laptop. I don't know if this computer's set up for it, but I'll probably use my laptop, and that way I can use Notepad++ for the example, which is a text editor with zoom features. So I can zoom in and out and make the text look really big for the video call or to project here on the board, so y'all can see it. at least really make it big for the Zoom call, so that way everybody can see it clearly on the screen. In the past, when everything was still in the classroom, I already set up like Hangouts calls. Austin probably remembers this. I would use Google Hangouts and just project my screen across the internet anyway, because programming examples are typing text. And that's really, really hard to read from across the room, especially when all the computer people are in the back of the room. Computer people never sit in the front of the room. That back row gets full. But it's hard to read that. So I'll probably use that, and Notepad++ is one text editor that has a Zoom feature. I'll talk about different text editors. Because really that's what it is. It's a text file of instructions that the machine knows how to turn into something it understands. Usually assembly language, but maybe a machine language itself or some sort of bytecode. We'll talk about those coming up soon. So that's one option. Just use text editors and make sure it's set up. If you need to set up environment variables on your machine, that's I set up some videos for that. If you're like a server administrator or something, and you think that the best place for you to practice Python would be running it on a server, I set up one of those videos online is how to set it up to run Python on a server. It's CGI script. Spider is a very popular IDE. Has a lot of very nice features, and I brought my laptop that's installed on just to have that here and left it in my office. So it has some nice features. I'll click on the link to look at the pictures. So there's a big editor. Lots of debugging features. I guess you can kind of see it up here in the picture. There's multiple play buttons. Where's my annotate thing? So there's a general play button to run all the code, but then there's a debugger play button so that we can step through the line, so we can step through our code one instruction at a time. Well, that's not a very good color. So yeah, a general play button and then a debugger button so that we can run through the instructions one at a time and run them. There's a big, really nice variable watch window, Explorer. You got to see it here in the picture. All of our types are color coded. We get the size it is in RAM, the value stored in it, the type of it, all the information about our variables. So we can pause the program at any point. Yeah, the picture shows the graphs because it can do nice graphing, but there's other windows we can put there. It uses iConsole instead of one of the shells, which is a much nicer place to run our Python code, basically. The terminal prompt looks different. It has square brackets instead of angle brackets in the Python terminal prompt. But that's a very popular one. I really, really like it. I may use that a couple times in class. It's open source. You kind of read about it and click the link, see if that's the one you would like, or
Do you
try
have to
several.
download extensions in that one too, like VS Code?
What's that?
Do you have to download extensions for each language you're trying to put through it?
Oh, that one only doesn't. That one's only for Python.
Oh, Spider's only for Python?
Spider is Python only. It's actually for deep learning algorithms. That's why they developed it.
Okay.
So it's written entirely in Python. That's another thing I really like about this one in class that uses Python. Is this IDE is a very, very powerful IDE. There's actually the original intention was it was AI researchers at MIT that developed it. And then they just kind of got with some other computer scientists there and cleaned it up and actually released it. It's a really nice one, but it was entirely coded in Python. Every bit of that. So it also shows how powerful Python can be. So that's a really nice IDE. You want to try that one. Idle is just the very generic one that comes with the install. When you install Python on your system, you'll have that. It has a few debugging tools. I'll probably pull it up at least once and point out how to use the debugging tools on it so you know what to do with them. How to pause the code, walk line by line through the code. It doesn't have very many debugging tools. It's very stripped down. Doesn't have very good prediction either, predictive text and all that. So
You
I'm
can
a
go
big
step by
fan of
step
those.
through your code in idle.
What's that?
You can go step by step.
Yes. Yeah, there's a debugger there. it's kind of hard to use the debugger. But it is there. The one in Spider is a lot nicer, or PyCharm is by JetBrains. It's actually, yeah, it's more like Eclipse or some of the big ones, Android Studio. A couple of the really big ones that you're thinking of where all the different languages are separate plugins. PyCharm started as that, but the plugin got so big they just made it its own version of, I think, Eclipse. It might have started as something different, but I'm pretty sure it started as Eclipse and they kept growing and growing and growing. And then finally it was just too much to call a plugin. Like, yeah, we can't call this a plugin anymore. This has to be a separate version. And along those lines, Visual Studio Code Zero. So that's become very popular, the lightweight one, not Visual Studio, the big one that takes like 15 gigabytes of storage space on your computer. But there is a small one that is just more like a super fancy text editor.
Yeah, my buddy introduced me to VS Code over the summer, I think. I was like, this is so much better than just the title.
Yes. And it's stripped down, so it has the important features. So it doesn't seem like a full IDE compared to others. To me, it feels a lot more like a text editor, closer to a text editor, but kind of a step above, like when you pay for Sublime Text Editor, those features you get when you pay for it, or some of the stuff built into Atom Text Editor. So it's stripped down. You're not going to get lost in it like you do with Google IDE. That's become very popular lately. Lots of different options. You can just Google Python IDEs. And now they put it on there. Okay, another popular one, Ripple.it, REPL. They decided to pronounce it Ripple. This is an online IDE, cloud-based thing. I really like this one. Like most cloud stuff, it allows for multi-user editing. So multiple people can edit at the same time, and chat rooms and all of that stuff. Like you probably used to in Google Docs and other things online. I really like this one. It's like if you send me a text or call me at 11:30 at night some night and panicking, can't get your program to work, we can hop on here and use the chat features to work on a program at the same time and see it. So it's a nice IDE for that. It has a lot of features. A very powerful one. There's a huge list of languages down here at the bottom. You see all different languages that it knows. Python should be on this list somewhere, but it doesn't seem to be in. Doesn't seem to be in alphabetical order. I see Pygame, but I don't see full Python. Oh, there it is. It always seems weird when lists aren't in alphabetical order. I was like, oh, that seems like it would have taken some effort to do this. I don't know my login for that. But it knows lots and lots of languages and an online IDE, very powerful tool. Maybe I know my language. Does Google know my? This is in there. I don't know what it is. Oh, that was it. Okay. I always like when I guess the password on the first try.
Yeah, it wasn't that smooth the last time. it took a minute last time.
Okay, yeah. So we can they're call them ripples. I would have pronounced that repel myself or something like that. But they call them ripples, and lots of languages that it knows, along with Python, JavaScript, C, Java, Ruby, Scheme, Rust, Clojure, Kotlin. You can see I'm not even reading everything on that list, but the list goes on and on and on and on. I've been talking for a minute, and I'm just going to stop scrolling and go back up to Python. So he knows lots and lots of languages. And it's kind of like the one in the textbook. There's a place to write your code. You'll notice when it's blank here in the text editor portion, there's a link here that says examples. So you can pull up some stuff getting started. That's been there for a while. A new feature they added in. Well, I don't see the button here. I must have moved it. Maybe it's under examples. Well, somewhere in here, there's a button that links directly to YouTube tutorials now. So when you start to write stuff in Python, there's a button somewhere on the page that will just open up, go directly to YouTube tutorials for Python. So you can learn the language right from the IDE with all those online features and stuff. So yeah, it's basically just write your code here. What's the basic? Print hello world. And run your code and it shows up over on the right side. All the normal predicted text and things we would expect. So that's a nice one too. I really like that one. And online features are nice. If you work with your classmates or call me in the middle of the night, that's a good way to address this stuff. So lots and lots of places. Spider can be really very powerful, very useful. The variable explorer there is especially useful in the debugging stuff. For this class, I will be using mostly just the text editor and the terminal. Because in class, I like to throw the error messages in order to address it, right? Everything in the book, this is down to the final graph, so all the Python code you see in here runs perfect, right? I assume everybody has experienced that that's not what happens when we go write our code. We make typos and we get error messages. So in class, I like to see those error messages and learn how to deal with them instead of trying to avoid them. So we'll see lots of error messages, and I'll go right to the basic text editor so it doesn't autocorrect that stuff. So before Monday's class, make sure you have your computer set up for some sort of, with some sort of development environment for Python. Be your choice, whatever you want, because ultimately it's just a text file that you will send me for grading or submit to the book for grading. So yeah, you'll have the one in the book you probably noticed doesn't have nice features. So you'll copy and paste those starting points into it. Something that does have nice features, like all the debugging tools in Spider, the step-by-step and the variable monitor, watch window, and use those to get your code running, and then copy and paste it back to the book to run it. You'll probably want to do something like that. And the online examples, so you might, especially those on a Zoom call, you might want to make sure you have some sort of setup going where you can follow along the example. Somehow follow along the example in class, and like see it and hear the Zoom call, or it's being recorded. So maybe if you prefer, you can just take notes during class, and then in those notes, make little timestamps of when something was covered, so you can quickly zip through the video and see it. We'll get started into all that this coming Monday. So we can maybe start kind of giving some of those a try. And remember, this class is about the tool. We're studying the tool. There's lots and lots of ways we can use a tool. So we'll get started into that. And hopefully it'll be an enjoyable class. Programming can be a lot of fun. I feel like it's like a puzzle or a game. You get that a challenge to overcome, that accomplishment that comes at the end is very rewarding. Or lately, I've even started calling it artistic thing, just with data as the medium instead of paint or sound in the case of songs or whatever. But hopefully it'll be very enjoyable, and we'll get started with examples and stuff on Monday. Does anybody have any questions? No questions here. Everybody on the Zoom call, okay?
Yeah, I don't have any questions.
Okay, yeah, and I think Madeline had to leave early, but she is quite confident with Python already. I've seen her stuff. So she just has to sit through. Sometimes we just have to sit through courses, right? It's like, oh, I know this, but I don't have I don't have the paperwork that proves I know this. I encountered a whole lot of that on my way through school. So if you're ever have me for a course like that, where you know the stuff, you just don't have paperwork that proves you know it, and would like to do something more interesting, let me know and we'll find something more interesting to do so that you don't get bored out of your mind in the class because it's something you already know and you just have to sit through it. There's always more interesting things we can do. But otherwise, y'all have a good weekend. I will be here for the next hour till 9:50. If you have any questions, Ivy learn messages and text messages make noise on my phone. I can jump back on the Zoom call immediately or in the classroom. There in the classroom. But otherwise, I will see you all on Monday. Everybody have a great weekend. If you end up with any questions, let me know. You don't have to wait for my office hours or anything. Those are just the times I know I will be sending questions. So see you all on Monday.
Thank you. Have a good night.